Juan purchased an antique with an initial value of 200. Each year the value is estimated to increase 10%, so that's 100 plus 10 divided by 100, or 1.1. And I'm going to put t as my exponent because that's every year, and t will represent 1 year. So if we want to look at 2 years after purchase, this is how we would find that value, 200 times 1.1 times 1.1. So that's what A represents. You could also look at this like 11 times 11, which is 121, and then move the decimals back over. GDP of Malta was 250 million in 1970, and we increased by 15% per year compared to the previous years. So we're looking in millions, so we'll start with 250.72, and we'll multiply by 1.15, that's the 15% per year, t years after 1970. Our initial value here is 9. We're multiplying by an increase of, 33%? Since it goes up by 3 and then it goes up by 4, and that's 1/3 each time. So I'll multiply by 1.33 raised to the power of x. So the value of r is 1.33. Colony of bacteria began with 1 cell. That's my initial value. It doubles. I'll put a growth factor of 2 every 20 minutes. So x, where x is equal to 20 minutes. So how many times does 20 minutes go into 2 hours? That's going to be 6. So 2 to 6 is my answer, which gives me 64. 3,000 students initially. There's going to be a decline of 2%. So I'll multiply that by 0.98, or 100 minus 2 over 100. And t, or I guess x, for the number of years after that. So if there's a y-intercept of d, that means when x is 0, y is d. Which means if I plug in 0 for x and that part goes away, my starting value is d. So there's some growth factor to the power of x with an initial starting value of d. The only one that has that is this one. So if t represents years, and we want to change that to q, quarter years, we can change that to q over 4. Because that way 4 quarters will still equal 1 year. Everything else in the equation stays the exact same. So in the original equation, t represents years. If we want to change that to months, we're going to change that to m divided by 12. That way every time we hit 12, we are increasing at the same rate we would if the variable was just t. So this one has m over 12 as the exponent, though it's kind of hard to see, and that's the best choice. Which of the following functions models p of t, the number of pollen grains per square centimeters, t years after the first grains were deposited? So we start off with 310, that should be in the first position. 1% annual increase, that's 100 plus 1 over 100, or 1.01 raised to the power of t. So we initially took 30 minutes to complete a task. I'll put 30 in the front. And the time it took decreased by 5%. So that's 100 minus 5 over 100, or 0.95. This represents exponential decay. And we'll raise this to the power of x for the number of hours. The world's population has grown at an average rate of 1.9%, so that's 100 plus 1.9 divided by 100, or 1.019. There were 4 billion to start, so we'll do 4 times 1.019 to the power of t, which matches A.